Question asks, consider the carbocation below. Will the carbocation rearrange? Why or why not? So to answer this question, we have to kind of take stock of the carbocation that we have. And then we have to think about, is there a way to make it more stable? So let's kind of use the process that we've discussed to do that. So first off, let's recognize that we're dealing with a secondary carbocation right now. Secondary carbocations can become more stable. They can become like a tertiary carbocation, or they could become like a secondary carbocation with resonance. So we could definitely make this more stable. Next up, let's consider, are there any neighboring protons or methyl groups that we could shift? Okay, so on this adjacent atom, there are 2 protons. And over here, we have a proton and a methyl group. So we could, in theory, switch any of the protons or that methyl group over to become, to see if we can make a more stable carbocation. So let's kind of go through the process. First, let's try the hydrogens over here on the right. So we'll call these hydrogen 1s. It doesn't matter which one we switch, it would still make the same carbocation. So if we moved one of those over, then we would create a carbocation that looks like this. This is still a secondary carbocation. So that one's not going to happen because we don't increase the stability of our molecule. Next, let's consider the hydrogen on the left side. So if we move that over, then we will create a carbocation that looks like this. This is a tertiary carbocation, so it has increased in stability. So that's very promising. Let's be thorough, though, and see what happens if we try to move the methyl group over. If we try to move the methyl group over, we would make this carbocation, which is secondary. So again, that one won't happen because it doesn't make the carbocation more stable. So the only rearrangement that's possible is this one. And yes, it will happen because it can make our carbocation more stable. So the answer to the first question, will the carbocation rearrange? The answer to that is yes, it will. All right, so we can cross off answer choices B and E from our options. Next, we have to figure out, why does it change? So we have to kind of look at the reasonings of our answer choices. So the first one says, yes, the carbocation will rearrange via hydride shift. So that's true. That's what we found, to become a more stable tertiary carbocation. So A checks out. If we look at B, yes, the carbocation will rearrange via hydride shift to become a more stable secondary carbocation. So that doesn't make any sense. C says, yes, the carbocation will rearrange via methyl shift. So that's not correct. That means our answer is answer choice A. Yes, the carbocation will rearrange via hydride shift to become a more stable tertiary carbocation.